What evil lurks in the hearts of coronal holes? The Smasho knows. And thanks for tuning in to our space weather in-depth coverage. We'll be looking at fields, features, sunspots, flares, and more. And let's look at the Geospace Magnetosphere Movie, showing magnetohydrodynamic pressure modeled in nanopascals around planet Earth. It's Earth's magnetic moment from space. It's what a proton experiences. A solar wind proton, for example. It orients to these magnetic fields. And these magnetic fields are the reason why protons don't just rain freely down upon your head. That's the last 4 hours. Courtesy University of Michigan, we'll let that play through as it refreshed, and we want to get these videos onto your screen as quickly as possible. Take a moment to press like and subscribe. Press the notification bell if you haven't done so. Most of the pressure here oriented on the magnetotail side, the non-sun facing side of the planet, the dark side of the planet, as the plasma pressure is reaching equilibrium. Here's the GOES magnetometers over the past 3 days. We can see some maneuvering happening there. That's what these arc jet moments are. That's when they turn on their thrusters to maintain their near equatorial geosynchronous orbits. It produces plasma, which can affect the magnetometer readings. For all of you who think NASA's hiding data, right there's the data. And we are in the process of switching current sheets. In fact, that moment may have been right here. That would be my best guess, as when we look at the heliospheric current sheet in a moment, you'll probably agree. Next, ground magnetic perturbations, Earth's magnetic moment from the ground in nanotesla magnetic flux density. Like the first Geospace Magnetosphere movie, that's 4 hours of data. Interpolated by the space weather modeling framework, creating this great model, courtesy University of Michigan. Next, we'll go to the real-time solar wind. We've seen a recent small uptick here in the solar wind density. Made it down to about 4 protons per cubic centimeter. Now it's up a little bit to about 5.5. Make it 6.5 protons per cubic centimeter. Solar wind speed 410 kilometers a second. We are expecting some high-speed coronal hole winds. So it's a matter of watching the data here. We're expecting a density spike, and then a density drop-off, and then a velocity spike when the density drops off, the signature of a coronal hole wind stream, as well as a coronal mass ejection. We are expecting a coronal mass ejection to show up early in the day tomorrow on March 27th. KP index at 1. That's a measurement of global geomagnetism. Conditions are quite calm at the moment. And here's the heliospheric current sheet. Earth is likely in a South Pole current sheet by the time you see this video. This data was an hour old when we made the video. There's the South Pole current sheet. There's the North Pole current sheet. Stereo B is still in that current sheet. If you're wondering where this data comes from, it's from 51 ground-based magnetometers, magnetometers on Stereo B at Lagrange 4, and Stereo A at Lagrangian 0.5. Let's take a look at it from the line of sight perspective. This also shows the solar magnetogram. We show it daily as we're interested in the progression of the solar polar field reversal process and sunspot cycles, since we're writing a paper to explain the mechanism underlying them. Next, line of sight coronal hole plot. You can see some South Pole oriented coronal holes rotating in here from the east, basically in between sunspot 2974 and sunspot 2975. We'll get to those in a moment. And the high-speed coronal hole wind streams that we're expecting are from this series of North Pole-oriented coronal holes shown here in green. And those are what we started out this video with. Here's a zoomed out view in that same wavelength, 193 angstroms. One of the best wavelengths to show coronal holes. Also 211. You can try that one out if 193 isn't striking your fancy. Sun's been rather calm over the past 24 hours. Let's move to sunspots. So sunspot 2974 has degraded a bit. There is a new active region here, sort of ahead and a little bit to the north of sunspot 2975. Oh, there's been a new sunspot named here also. The trailing umbrae are now considered sunspot 2976. So we've got two groups there. And I think the likelihood of flares has gone up a little bit as this leading umbra has been speeding away from the rest of the sunspot group. We'll show you that in a moment. You should be able to see it from this view here, 1700 angstroms. And let's move to sunspot 2974, the one that produced that M-class flare. I think it's shrunk a little bit in the past 24 hours. Mostly stable. A bit of a trailing umbra there also growing. Maybe this is fixing for some more solar flares. Yeah, it looks like it's actually gained a trailing umbra there over the past 24 hours. And here's a close-up of 2975. This leading umbra here has been sort of rotating a little faster than the rest of those. And this is now sunspot 2976, this group back here. So this is one group, and then this is the other group, 2975 and 2976. Great footage there from the SDO. Also a light bridge forming here across sunspot 2976 main umbra. We call that a light bridge. And a great view of that. No major flares. No major flares over the past 24 hours here. There was an M-class flare yesterday. We covered it yesterday. No spikes in the proton flux to speak of. It's pretty flatlined here. And let's take a look at the solar system. To do a solar system forecast, we'll give you the 1 week. There's where things will be in a week. And we've got Mercury showing up on multiple instruments here. So we're going to show you the coronagraphs in a moment to close out the video. First, a star chart. We're always interested in what's going on above our head. The blue line is the galactic plane. The yellow line is the ecliptic, the path the sun will take across the sky. And over Lehigh Valley, Pennsylvania, we've got the Moon, Mars, Venus, Saturn, and Jupiter rising ahead of the sun. If you've got a low horizon and you're up before dawn, you may want to check it out. Mine faces the south. I'm currently facing the south, and so does my sofa. Next to coronagraphs, we've got Mercury showing up on both. Also a far side coronal mass ejection. So here's stereo A's coronagraph that's located out here at Lagrange point 5. And here's the SOHO-LASCO C3 located at Lagrange point 1 in between the Earth and Sun. It may look like a halo ejection. It's not. It is on the far side. You'll be able to see it here on stereo A. You see that far side CME. Nothing on the earthly side there. No additional coronal mass ejections headed our way at the moment. We've got Mercury showing up on both coronagraphs here. Keep in mind the LASCO C3 has a much wider field of view. And we'll bring up some additional spectacular solar imagery for you here. Here's a close-up in 171 angstroms. From the SDO, it's sunspot 2974. And we'll also show 2975 and 2976. Some great filamentary activity there. You can see that up in your upper left of your screen. We'll let that play through a third time for you here because it's just spectacular imagery. From the Smash News Network, least busted name in news. In any case, thanks for tuning in to the Daily Space Weather. Congratulations on realizing the channel exists. May that solar wind be at your back.